So today we're going to expand and compress the quadratic relation, or hyperbolas and ellipses. So for hyperbolas from last day, we have x squared minus y squared equals plus or minus a squared, where plus will give us the trans x and minus gives us trans y. Now, for the ellipse, we start with the circle, which is similar to the hyperbola, rectangular hyperbola. So x squared plus y squared equals r squared. And when we compress and expand this circle, in fact, if we start with the unit circle, we have the a value being a horizontal expansion compression factor, and the b value being the vertical expansion compression factor. Okay, so expansion compression along x for A, expansion compression for B for along the y. Now, A being bigger means it's an expansion, A being smaller means compression. So we want to put it into that form to be able to determine what these ellipses look like. So to do this, I first take that x squared plus y squared over 9 equals 1. And I'm going to put that over the x squared over 1. And that 1 represents the a squared value. That makes the a value equal to 1. The y squared over 9 makes b squared equal to 9, which makes the b value equal to 3. So what that means then is that a value gives us the x-axis radius, and the b value gives us the y-axis radius. So I can draw my point in here and here. That represents the distance from the center to the edges along the x. I could put a point at 3 and -3, and that gives me the point along the y. So then sketching in this, I can just connect those, the vertices. Okay, so that gives us the ellipse that has that shape. Let's try that one more time. Okay, so then we have the ellipse with the major axis along the y and the minor axis along the x. Okay, so the major axis meaning the longer side, the longer axes, and the minor axis being the shorter one. So that's along the x for this one, and the major one, the longer one, is along the y. So these are non-rectangular ellipses and hyperbolas. So when we talk about rectangular hyperbolas are symmetrical along x and y, and circles are symmetrical along x and y. So non-rectangular hyperbolas and ellipses go together. So here we have our circle. We go from circle to ellipse by that a squared and b squared factors. Okay, they represent expansions and compressions along the x and y. And for hyperbolas, it is the same thing.